Am I audible?
Yes, sir.
Okay,
Yes, sir.
we'll get started. We'll get started. So we were doing Bayes theorem based problems, right? So let's see. So let's do example number 21 now. So we know this, right? The only thing we'll recollect the formula. Probability of EI given A is equal to probability of EI into probability of A given EI divided by what, guys? Sum of probability of EJ into probability of A given EJ, where J is going to vary from where to where? 1 to N, where E1 to En are what kind of events? They are mutually exclusive and what? Are they only mutually exclusive?
Exhaustive.
Yes, they should be mutually exclusive and exhaustive as well, right? So let's solve this problem. So man is known to speak truth 3 out of 4 times. He throws a die and reports that it is 6. Find the probability it is actually 6. Okay. So what are the 2 events that is done by him? Solution. So what are the event? What are the values of E1 and E2 that we are supposed to define? What is it, guys? So E1 is the event of 6 appearing. E2 is the event of 6 not appearing. So what is the probability of E1? What is the probability of E1, guys?
1 by 6.
It is 1 out of 6. What is the probability of E2? It is 5 by 6, right? So they both are mutually exclusive, and they are exhaustive as well. So what will be the event A? Event A is man speaking. That is man reporting 6. Okay. So what? No. Actually, man is reporting 6 is the event. Truth or false, that we will see later. So what is the probability of the man reporting 6 and it is 1 by 6? So what is the meaning of this? This is probability of man reporting how much? 6, and the die also shows 6. Means what is it? What is the probability? So indirectly, can I say that he has spoken truth? So how many times does he speak truth?
3 times.
Out of 4. Right? 75% he speaks truth, 25% false information. So what is the probability of A given E2? It is 1/4. 25% he is speaking false. He is giving false information. So what is the probability that the event of 6 has appeared and the man has also reported 6? So it is probability of E1 into probability of A given E1 divided by probability of E2 into probability of A given E2 plus probability of E1 E given E1 E2 into probability of A given E2. So if substitute all the values, you will get the answer. So what is the probability of E1? 1 by 6 into probability of A given E1 is 3 by 4. So 1 by 6 into 3 by 4 divided by 1 by 6 into 3 by 4 plus probability of E2 is 5 by 6. So 5 by 6 into 1 by 4. So that part you can substitute and find it out, right? Is there anyone having a doubt in this question?
No, sir.
Good. So make a note of this. I'll proceed to the next question. Now listen. So I'm moving on. I will start solving exercise 13.3 NCERT page 555. Right. So look at the first question. There is an urn which contains 5 red and 5 black balls. A ball is drawn at random. Its color is noted and is returned to the urn. Moreover, 2 additional balls of the color drawn are put in the urn and the ball is drawn at random. What is the probability that the second ball is red? So look at the subsequent events. No? What are happening? So initially, the urn contains how many balls? So solution. Let's make a note of all the data that they have given. So urn contains how many balls? 5 red and 5 black balls. Right. So it contains 10, out of which 5 are red and 5 are black. There is a ball that is drawn at random. Okay. So they didn't mention what is the color. So when they drew a ball from the bag, it could have been a red ball. So what is the probability of red ball? It would have been 5 by 10. It is 50% chance. What is the probability of black?
1 by 2.
It is also 5 by 10. It is also 1 by 2. But what are they asking? What is the probability that the second ball is red? So how do we know? So now observe, if first draw was a red ball, okay, then what would have been the probability? Then the total probability would have been probability of getting red in first draw, and subsequently what is going to happen? 2 additional balls of the color drawn are put in the urn. So now how many balls would have got added to the bag? So I will write down the statement again. Listen guys, see. I'm not sure because of no response. I'm repeating it again, listen. So had the first draw given you a red ball, what would have been the subsequent process they would have followed? If red ball was drawn in the first attempt, if red ball was drawn in first attempt, then 2 more red balls would have got added. Accepted? So when this happens, now how many red balls? Now the bag contains what? How many red balls?
7 red
7
balls.
red and 5 black balls. What are they expecting? What is the probability that the second ball is red? See, the probability of second ball being red is decided by the probability of the first ball also. So in this case, what would have been the probability of getting a red ball? The second scenario. So this is in first
7 by
draw.
12.
7 by 12.
That's it. 7 by 12. So according to this process, probability of getting red ball would have been 5 by 10 into 7 by 12. Why I'm writing 5 by 10 is because initially if that 5 by 10 would have got succeeded, then 2 more balls would have got added. That is why we are getting a 7 here. 7 by 12. So that is nothing but 7 divided by 24. Let this be first option. But this is not the only possibility, right? What could have happened? if first draw gave a black ball, then we have found the probability. Probability of getting a black ball is 1 by 2. Then 2 black balls would have got added to whom? To the urn. Now how many balls will be there? Now how many balls will be there, guys?
7 black
Now
balls.
number of balls will be 5 red and 7 black. So what is the probability of getting red in second draw? It is 5 out of 12. Observe here it was 7 out of 12. That 7 came because initially it was a red ball. So what is the probability of getting red ball? I'll put it like this. What is the probability of getting black ball in first draw and red ball in second draw? It would have been 5 by 10 into 5 by 12. That is 5 divided by 24. Guys, accepted? Did you understand what I did?
Sir,
Right?
can you repeat that point, sir?
Which point?
Last one, sir.
See, here, probability of red ball in the second row is 5 by 12. Did you understand why it is 5 by 12?
Yes, sir.
Because in the first attempt, you got a black ball. So no, you added only black balls. But what is our objective? We need a red ball. Our objective is to find what is the probability of getting a red ball. So the numerator didn't get affected. The denominator got affected. So now observe, it became 5 by 12. Initially, it was 5 by 10. So probability of getting a red ball in the second draw, that's what the question is. So probability of getting a red ball in the second draw is dependent on what ball you have got in the first attempt. So probability of, suppose this is the subsequent process that is happening. You got a red ball in the first draw. 1 minute. Suppose you got black ball in the first draw and red ball in the second draw, then the probability would have been 5 by 10. Probability of getting a black ball in the first draw, that is 5 by 10. And means into probability of getting a red ball in the second draw, which is 5 by 12, which gives you 5 by 24. Whereas in the previous process, what happened? You got red ball in the first draw and red ball in the second draw. So probability of getting a red ball in the first draw was 5 by 10. And probability of getting a red ball in the second draw was 7 by 12 because the numerator got affected. There it is 7 by 24. So in the overall process, what could have happened is you could have got a red ball in the first draw and red ball in the second draw, or you could have got a black ball in the first draw and red ball in the second draw. So what is the total probability? It is 7 by 24 plus 5 by 24. It is 12 by 24. That is 1 by 2. Darshini, are you clear?
Yes, sir.
Yeah. So the answer is 1 by 2. If there is anyone still not convinced, let me know. Okay, here there is no need of any Bayes theorem. It's actually, I don't know why they have given this problem here, but it doesn't need any Bayes theorem. It's a basic probability based system. Okay. Shall I move on, guys? Shall I go to the next one? Yeah, right.
Yes, sir.
second. So there is a bag which contains 4 red and 4 black balls. Solution. So it has 4 red and 4 black balls. Another bag contains 2 red and 6 black balls. One of the 2 bags is selected at random and a ball is drawn from the bag, which is found to be red. Find the probability that the ball drawn is from the first bag. So it's very simple. So event 1 is to select bag 1. Event 2 is to select bag 2. Right? What is the event A? Event A is, it should be a red ball. Okay. What are they asking? What is the probability that the ball is drawn from the first bag, known it is a red ball, is equal to what? Probability of A into probability of E1 into probability of A given E1 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Right? So what is the probability of E1, guys? So what is the probability of you selecting one of the bags?
1 by 2.
1
1
by
by
2.
2. The same as selecting the second bag also. So what is the probability of selecting a red ball from the first bag?
by 8.
4 by 8.
4 by 8. That is 1 by 2. What is the probability of selecting a red ball from the second bag?
2 by 8.
That is 1 by 4. 25% chance. Take everything, substitute it here, you'll get the answer. So for every problem, I'll do it till this step. Substitution part, you do it later. Okay.
Yes, sir.
So proceed. Of the students in a college, it is known. So it's a history they have in their hand. It is known that 60% reside in hostel and 40% are day scholars. That is, they don't reside in the hostel. So previous year results report that 30% of all students who reside in hostel attain A grade and 20% of the day scholars attain A grade in their annual examination. At the end of the year, one student is chosen at random from the college and he has an A grade. Okay. What is the probability that the student is a hostler? So what are the two events? So event 1 is student resides in hostel. E2, student is day scholar. Okay, what is the event A? What is the event we are concentrating on? Has an A grade. Getting an A grade. So what is the probability of E1? What is the probability of the student to be a hostler?
60 by 100.
So 60%. Every 6 students out of 10 stay in hostel and every 4 out of 10 stay outside. They reside as a day scholar. Right. So what is the probability of A given E1? What is the probability that the person has scored A grade, known that he is from hostel?
30
30
by
by
100.
100.
30 by 100. So it is 3 by 10. So probability of A given E2.
20 by 100.
20 by 100.
So it is 1 by 5. Right. Or we can leave it as 2 by 10 because the LCM you will get it as 10 itself. Okay. Now what is the exact question? What is the probability that the student is a hostler? Okay. So what is the probability that Student is a hostler, known that he has secured an A grade. So it will be probability of E1 into probability of A given E1 divided by probability of E2 into probability of A given E1 plus probability of E2 into probability of A given E2. Right? So all these values you can substitute. Okay. So moving on to the next one. Fourth one is, in answering a question on multiple choice set, a student either knows the answer or guesses it. Okay. Let 3 by 4 be the probability that he knows the answer and 1 by 4 be the probability that he guesses. So all this information that is given are the events. So event 1 is what?
Knows the answer.
Knows the answer. E2 is guesses the answer. So by now you should have understood that the events are supposed to be exclusive and exhaustive. Means when you add them, the probability should come. When you add their probabilities, it should come out as 1. Right. So what is event A? That's what we need to see. Assuming that the student who guesses at the answer will be correct with the probability of 1 by 4. What is the probability that the student knows the answer, that he has answered it correctly? So what is the event A? Event A is answer being correct. What is the probability that the student knows the answer given that he answered it correctly? So this correctly is the event A. So in the events E1 and A2, A is an event associated with it. So what are they asking? Probability of, can you guys tell me the mathematical expression what they're asking? What is the probability that the student knows the answer? So given that he knows the answer and he answered it correctly. Right. So for this we need probability of E1, that is 3 by 4. Probability of E2, that is 1 by 4. Probability of A given E1 is how much? Probability that the student knows the answer and he answered it right. So probability that the answer is right and he knows the answer, how much is it?
1, sir.
It is 100%. No, because he knows and it is right. So it is 1. So what is the probability of A given E2? So probability that he has got it right, but he has guessed it. They have given it. It is 1 by 4. So take all these values, you know the formula, substitute it, you will get the answer. So it's the same formula again, right? The same formula. You guys can substitute and find the answer. Copy it. So going forward, I will write it as sigma P of EI into P of A given EI. Or I'll write J, where J is equal to 1 to 2. Right? I hope you're able to understand how to take the data and how to solve the problems, right? Is there anyone having confusion?
No, sir.
Good. So I'm moving on to the next question. So in a laboratory blood test is 99% effective in detecting a certain disease. When it is in fact present, means a disease is there and the test has identified, yes, it is there. However, the test also yields a false positive result for 0.5% of the healthy person tested. That is, if a healthy person is tested, then with the probability of 0.005, the test will imply that he has the disease. Means actually he is not having, but it's showing it that he has. If 0.1% of the population actually has the disease, what is the probability that a person has the disease given that his test result is positive? So what are the events? Tell me. So what are the two exclusive events that are possible in this whole process? So the whole process is about testing, right? So when they are testing it, even the event of person having disease, then E2 will be what? Person not having disease. Okay. Now, what is the event A? Event A is the testing process, right? So test should show what? Should be positive. So what is the probability of E1? What is the probability that the person is actually having a disease? 0.1% actually has disease, right? What is the probability of a person having a disease? Guys, is there any point that is confusing you? Is there no, right? So then what is the probability of E1? So E1 means the person is having disease. Out of the whole population, how much percent is actually having the disease?
0.1%.
So 0.1 by 100, that is 0.001. So 0.001 is the probability of E1. So what is the probability of E2 then? 1 minus 0.001 means the person is not having disease. So how much is it?
999.
So 0.999. So what is the probability that the person tested positive and he has the disease?
99 by 100.
Yes. It is 99 by 100. So 0.99. So what is the probability that the person tested positive but he doesn't have the disease?
0.005.
0.5 divided by 100, that is 0.005. So what are they asking? What is the probability that the person has the disease? So what is the probability that the person has the disease and he tested also positive? Take all the values, substitute it here, you will get the answer. I suggest you guys to deal it in fraction itself. So I hope it is clear. Shall I proceed? Sorry?
Yes, sir.
No. So read the sixth question. You people try. So there are 3 points. So how many output sample space contains? Whenever you see 3 points,
216.
it is eight outputs. One is a two-headed coin having head on both the sides. So it's a biased coin. So another one is a two-headed coin. Another is a biased coin that comes up. It's 75% of the time. And third is an unbiased coin. One of the 3 coins is chosen at random and tossed. It shows heads. What is the probability that it was the two-headed coin? So how do we define the events? Solution. What are the events? E1 is what?
Two-headed coin.
So two-headed coin. Let's go in the order. E2 is what? It's a
Bias coin.
biased coin. E3 is what?
Unbiased
Unbiased.
coin.
What is event A? It shows heads. Getting heads. Right? So what is the probability that it was a two-headed coin, knowing that he has got hit? So it will be probability of E1 into probability of A given E1 divided by all those things will come. So what is the probability of E1? So what is the probability of you getting a two-headed coin?
1 by
So
3.
how many coins you have in your hand? You have 3. Out of the 3, you getting a two-headed coin is 1 by 3. Same as the probability for getting an unbiased coin, biased coin. Same as the probability of getting an unbiased coin, because they are equally likely to happen. So what is the probability of A given E1? So what is the probability of getting hits?
1.
That you know it has come? It is 100%. So what is the probability that A given E2? They have given the answer. 75% times.
3 by 4.
So it is 3 by 4. So what is the probability of A given E3?
1 by 2.
1 by 2.
1 by 2.
Take all these values, substitute it, you will get the answer. Next question. So there is an insurance company which has insured 200 scooter drivers, 4,000 car drivers, and 6,000 truck drivers. The probability of an accident, the probability of an accidents are, the probability of an accident are 0.01, 0.03, and 0.15 respectively. So one of the insured persons meets with an accident. What is the probability that he's a scooter driver? Solution. What are the events? Let's go in the order. Scooter driver, event 2 is
Car
Car
driver.
driver.
car driver, event 3 is truck driver. Right? Event A is accident occurs. Okay. So what is the probability of E1? So totally, how many people are there? 2,000 plus 4,000, 6,000 plus 6,000. There are 12,000
12,000.
people. So out of 12,000, there are 2,000 scooter drivers. So probability is going to be 1 by 6.
1 by 6.
So what is the probability of E2? 1 by 3. Probability of E3? 1 by 2.
1
1
by
by
2.
2.
So what is the probability of A given E1? So probability that the person has met with an accident knowing that he is a scooter driver is 0.01. So probability of A given E2 is 0.03. That's given in the question. Probability of A given E3 is 0.15. What are they asking? What is the probability that he is a scooter driver? So what is the probability that he is a scooter driver known that he has met with an accident? You know the formula, you have all the data, substitute it, you will get the answer. So it's better you convert everything to fraction and then solve, don't deal with decimals. There is a high possibility will go wrong. Okay, so since this is an easy question, I'm going to the next one. 8th one. So factory has two machines, A and B. Past record shows that machine A produced 60% of the items of output and machine B produced 40% of the items. So they both are, so even before I complete the question, I'm able to understand 60 plus 40 put together is 100. So event is about choosing a machine. Okay. But let's read. Further, 2% of the items produced by machine A and 1% produced by machine B were defective. Okay. all the items are put into one stockpile and then one item is chosen at random from this and it is found to be defective. What is the probability that it was produced by machine B? So event 1 is product from machine A. E2 is product from machine B. What is the event A?
Defective.
Item is defective.
So item is defective. Now let's write down. So what are they asking? What is the probability that it has come from machine 2 and we know it's a defective one? So that is probability of E2 into probability of A given E2 divided by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. So what is the probability of E2, E1 guys? So product produced from machine A, it is 6 by 10. 60 by 100, no? Probability of E2, 4 by 10.
4 by 10.
So probability that it's a defective one, known that it has come from 1 is
2 by 100.
2 by
2 by
100.
100. Probability of A given E2,
1 by 100.
1 by 100.
You have all the data substituted, that's it. Right. Moving on to the next one. Look at the ninth one. Two groups are competing for the position on the board of directors of a corporation. The probabilities that the first and the second groups will win are 0.6 and 0.4% respectively. That is put together is 1. Further, if the first group wins, the probability of introducing a new product is 0.7 and the corresponding probability is 0.3 if the second group wins. Find the probability that the new product was introduced by the second group. Means what has happened? Probability that the second group has won and they have introduced the product. Solution. What is event 1? First group winning. Event 2, second group winning. Event A, what is the event A, guys?
Invented by second group.
No, introducing new product. Right. Now what they're asking is, what is the probability that the second group has introduced the new product? What is the probability of E2 given A? Okay, for that we need probability of E1. What is the probability of first team to win? Is 0.6. That is 6 by 10. Probability of second group to win is 4 by 10. What is the probability that the new product is launched? Known that E1 has won. How much is this?
7 by 10.
7 by 10. Probability of A given E2.
3 by 10.
That's it. You take all these values and substitute, you will get the answer. So numerator will be this thing. So 4 by 10 into 3 by 10 is 12 by 100 divided by, multiply these two. So 12 by 100 plus 42 by 100. So it will be 12 by 100 divided by, how much is this? 54. So it will be 6 divided by 27, or that's it, right? 6 divided by 27, or it will be 2 divided by 9. Right. Moving on to the next one. Did you understand what I did? How I did the calculation? So I multiplied E1 with A given E1, E2 with A given E2. Since in this question, E2 is in the numerator, this product, the right side product will be in the numerator. So that comes. And the denominator will be sum of both the products. So 12 by 100 plus 42 by 100. So for every problem, this is the logic. Am I clear with this?
Yes, sir.
Okay. Let's look at the 10th one. Suppose a girl throws a die. If she gets a 5 or 6, she tosses a coin 3 times and notes the number of heads. If she gets 1, 2, 3, or 4, she tosses a coin once and notes whether a head or tail is obtained. If she obtained exactly one head, what is the probability that she threw 1, 2, 3, or 4 with the die? So what is the girl doing? She's throwing a die. So if the die rolls out and shows 5 or 6, then what will she do? She will toss a coin 3 times and she will count the number of heads. Okay. If she gets 1, 2, 3, 4, 5, 6, she tosses a coin only once and notes whether it is a head or tail. If she obtained exactly one head, what is the probability that she threw 1, 2, 3, or 4 with the die? So what is event 1 getting? 5 or 6. Right? What is event 2 getting? 1, 2, 3, or 4. What is event A getting?
One head.
One head. Okay. So what are they asking? What is the probability that she threw 1, 2, 3, or what is the problem? If she has obtained exactly one head, what is the probability that she threw 1, 2, 3, or 4? So probability of E2 given A is what they are asking. So what is the probability of E1? Getting 5 or 6 is 2 out of 6, which is 1 by
1
3.
by 3.
So probability of getting E2 is 4 out of 6. That will be 2 by 3. So what is the probability of A given E1? What is the probability of getting one head known that it is 5 or 6? So when she is tossing the coin 3 times, how many outputs come, guys?
8.
Out of the 8 outputs, what is the probability that you will get head? Exactly one head. So what is, for that you need to write those 8 outputs. No, what are the 8 outputs? H, 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 tail, 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 H, H, tail, tail, H, H, tail, tail, H tail, H tail, H tail, H tail. So how many events out of these 8 exactly has only one head? 1, 2, and 3. So it is 3 out of 8. What is the probability of A given E2? A given E2 means she is getting a head, and how many times is she tossing the coin? Only once.
1.
So 1 by 2. Because when you toss coin once, for the probability of you getting exactly one head is 1 by 2. So probability of A given E2 is 1 by 2. I'll write it here itself so that it's easy for us. So what will be the final answer, guys? So probability of E2 given A means, so what is probability of E2 into A given E2? That is 1 by 3 divided by 1 by 3 plus 1 by 8. That is, I multiplied these two. So 1 by 3 divided by 11 by 24. It goes 8 times. Answer will be 8 by 11. Clear?
Sir, how it is 1 by 2, sir?
See, what is probability of A given E2? What is the probability of the girl getting one head, known that she has got 1, 2, 3, or 4? So when according to the story, if she gets 1, 2, 3, or 4, how many times is she tossing the coin?
1 time.
One time. When you throw the coin one time, what is the probability of you getting head?
1 time.
No, that is 1 by 2. That is the reason why I wrote 1 by 2. Okay, whereas here what has happened is probability of getting a head, known that she has got 5 or 6. When she gets 5 or 6, how many times is she throwing the coin? 3 times.
3 times.
So when she's tossing 3 times, these many outputs are there. In these many outputs, what kind of output do we need? We need only outputs which have exactly one hit. So there are 3 outputs out of 8 which are having exactly one hit. Is that clear?
Yes, sir.
This is 10th one. Look at the 11th one. A manufacturer has 3 machine operators A, B, and C. The first operator A produces 1% defective items, whereas the other 2 operators B and C produce 5% and 7% defective items respectively. A is on the job for 50% of the time, B is on the job for 30% of the time, and C is on the job for 20% of the time. See, this A is defective. This A is something else. Okay, it's not mission A. A defective item is produced. What is the probability that it is produced by the mission A? This is the mission number. So solution. What is event 1? So here, which events are mutually exclusive and exhaustive? 50, 30, and 20. Time spent by operator A. So what is E2? Time spent by operator B. E3 is time spent by operator C. What are they asking? You have a defective item. So event A is what? Getting a defective item. Correct? So what are they asking? What is the probability that it was produced by mission A? What is the probability that the first mission has produced and it's a defective one? So for this, you need to know what is the probability of E1. So what is the probability of E1, guys? $50 by 100.
1 by
That is 1 by 2. So what is the probability of E2? 30 by 100. That is 1 by. How much is it? 3 by 10.
Yes, sir.
That is 3 divided by 10. What is the probability of E3, guys?
1 by 5.
1 by 5. Okay. So what is the probability that you got a defective item, known that it has come from mission 1? So first operator A produces 1% of
1
defective
by
one. So
100.
answer will be 1 by 100. So what is the probability that you got a defective one from second mission?
5 by 100.
5. What is the probability that you got from the third mission, A divided by E3? That is 7 by 100. So E1 by A means probability of E1 into probability of A given E1 divided by sum of all the values. So E1 is 1 by 2. So numerator will be 1 by 2 into 1 by 100 divided by denominator will be 1 by 2 into 1 by 100 plus 3 by 10 into 5 by 100. That is 1 by 10, 1 by 20 plus 1 by 5 into 7 by 100. If you calculate it, you will get the answer. Clear?
Yes, sir.
We'll do one last problem for the day. A card from a pack of 52 cards is lost. From the remaining cards of the pack, 2 cards are drawn. So from the 51 cards that are there, 2 cards are drawn and are found to be both diamonds. Find the probability that the lost card being a diamond. So what is event 1?
A card is lost.
See, event 1, if you take card as lost, then what will event 2 be? The cards which are remaining. If you take cards which are lost, then what is the probability of it? 1 by 52. Then cards which are remaining, 51. So you're trying to take them as exclusive. Okay, but here, see, 2 cards are drawn. It's not about the cards which are lost. 2 cards are drawn and found to be diamonds. Find the probability that the lost card is also a diamond. So card So here the exclusive events will be choosing a diamond and event 2 will be not choosing a diamond. Then what will event A be?
Last card is a diamond.
So event A will only be lost card. Okay. So what are they asking? What is the probability that the lost card is also the lost card being a diamond? So what are they asking? Probability of E1 given A. So what is the probability of E1 given A? That's what they're asking, no? What is the probability that you choose a diamond and it's a lost card? Okay. So what is probability of E1? What is the probability of choosing a diamond?
13 by 52.
What is the probability of not choosing a diamond?
39 by 52.
Right. So what is the probability that the lost card is a diamond? This is where we need to be careful.
1 by 13.
How did you say it is 1 by 13? How was it 1 by 13?
Totally 13 diamond cards. So
Okay.
one card is lost. So by 13. So
That's not the case. So okay, let's take
Okay,
1
sir.
by 13. Then what is the probability of A given E2 according to you?
So 39 by 51.
39 by 51. 39 by 51. Charge my pencil. Just a minute. You guys have time or you have any other class? So those who have any other class can leave. Just a minute. So 39 out of 52. That's not right. We have not involved this 51 anywhere. No. So find the property that the lost card being diamond. So probability of E1 given A will be, what is the formula? It is probability of E1 into probability of A given E1 divided by probability of E2 into probability, E1 into probability of A given E1 plus probability of E2 into probability of A given E2, right? So probability of E1 is choosing a diamond. Probability of A given E1 means probability of choosing a diamond, probability that it's a lost card and you have chosen a diamond. So this is where we need to think. And actually, what are you doing? You're drawing how many cards from? You're drawing 2 cards from the deck. From the deck of how many cards? 15 cards. So it's a process of selection, right? So this question, I think I'll get back to this. So this I need some time.
For choosing a diamond card, we are choosing from remaining cards. We are choosing from remaining cards, so it will be 51 of the denominator.
Well,
In that question.
A given E1, you're saying, huh?
Yes, sir. P of E1.
Are you talking about this part?
Yes, sir.
P of E1, you're saying. No. See, P of E1, what I'm doing is I'm talking about choosing a diamond. I never spoke about lost. See, this is a condition. A given E1 is a condition. Probability of you choosing.
We are choosing from remaining cards from the pack, no, sir. Then it will be 51.
No, it will not be 51. Then there will not be exhaustive events. No. See, for example, I'll answer your question. If you say 13 by 51, and how much will be the remaining then? How much will you write the remaining as? What is the probability of not choosing a diamond? Okay, if I put a question like this, if you write 38 by 51, I will say it is wrong. Why? Because you don't know, you have no information about the lost card. Hemant, are you able to understand?
Yes, sir.
So if you write like this and you say that these both are exhaustive events, that is wrong. Okay, when I say choosing a diamond, I'm talking about choosing a diamond from the whole lot. That is how we have defined the events. No, event one. So see, I'm repeating it again. If you have to apply Bayes' theorem, you need to choose the events such that they are exclusive and exhaustive. So what are the exhaustive events? Choosing a diamond and not choosing a diamond from the whole lot. Okay. So event A is about choosing a lost card. So I'm just trying to connect the dots. So probability of choosing a lost card, probability of getting a lost card, and it is a diamond. I'll think and get back, guys. I need to frame it properly. I'm not able to think also because there are many people who have to leave. I'll think about this and get back. The remaining 2 are only MCQs. You guys can try this. Okay. With this chapter is also over. Probability is over. Because the next 2 exercises are deleted and they are independent also. It is not there for CBSE. So with this, it's the end of probability. That question alone, I'll solve it. Don't worry. Okay. So remaining things you guys practice. If there are any doubts, you can approach me personally. Just give me a minute. I'll take some screenshots and you can leave.